Hi everyone. So we are going to be taking a look at Module 2 content in this video, which really is just about this new concept of linearization and graphing. So I'm going to kind of give you a quick tutorial on how to graph in Excel, but more so we're going to talk about what happens when we get trends that are non-linear. So in your initial reading, it talked about how you're going to conduct a proper experiment, which is going to be useful throughout the entire year. But what it does when it gets to that very end is it gives you this chart. And this chart is a good representation of all the different types of trends we're going to see throughout the year. The problem with these different trends is that it's going to be very difficult for us to form equations with something that is non-linear. You guys are very good with working with linear equations, but in order to actually apply polynomial and logarithmic equations, it gets to be a little bit more difficult in physics because you can't really see what all those parts mean. But a linear trend, so that y is equal to mx plus b, it's very, very easy to see what those different parts are. So your y is whatever is represented on your y-axis. Your m, you should know, is your slope. Your x is what is ever represented on your x-axis, and your b is just your y-intercept. So those are very easy things to see. Whereas polynomial, logarithmic, it's a bit harder to see those. So what happens is when we get these different relationships, we need to kind of manipulate our data in order to make it linear, so that linearization. So if we look at these three different types, the first one is a no effect. The second one is a linearized graph already. The third is an inverse. The fourth is a top opening parabolic relationship. And the fifth is a side opening parabolic relationship. Now, what those mean right now, those terms, that's not really necessary at this point. What is necessary is knowing what to do with your data in order to linearize so that we can actually form trends, or I'm sorry, form our equation. So what's going to be the most important thing for us is going to be this column right here, the modifications required to linearize your data. So you're going to have a chart that kind of looks like this. So you have your X and you have your Y. Remember that your X always goes on the left-hand side. Your Y, which is your dependent variable, always goes on the right. So you first have this data. And let's say we found that our relationship was an inverse relationship, so it's curving downwards. What we would want to do in order to linearize is take all of our X values and do 1 divided by each of those values. And then we don't do anything to the Y. And what would happen then is we would have a second data set and we would regraph that second data set. With the fourth one, we see that it's curving away from our X. So we actually go ahead and square the X values. Once again, we don't do anything with the Y. And then our last one, we're curving away from the Y, so we square the Y values. And in this case, we don't do anything to the X. So really, we're just manipulating the numbers. We're not changing what we saw. We still know that we have a top opening trend, but in order for us to form an equation, we do have to manipulate the data a little bit. And then whatever you do in order to linearize, you do to everything. So our standard equation is y is equal to mx plus b. Well, for an inverse relationship, since I did 1 over x, that x portion now needs to be 1 over x. For my top opening, since I squared the x values, x squared now goes into the equation. And for the last one, since I squared the y squared is equal to mx plus b. So whatever you've done in order to manipulate the data, you also do to your base equation. So you'll see me write y is equal to mx plus b as my line 1, and then my line 2 is however I changed it, so whatever I needed to do in order to linearize. So let's take a look at what would happen in our graph. So we have to start with that initial data. And in order to graph in Excel, we don't want to highlight first. You're going to find that your data and your chart's going to get all messed up if you try to do that first. So we're going to go ahead and click in a brand new box that doesn't have anything in it. And we go up to Insert, and we're going to go to Chart. Maybe. There we go. And you're going to see that it has no data. We want a blank canvas. So I'm just going to go ahead and move this over here. And then we're going to go over here to where we have setup and we have x-axis. Where it says add x-axis, I'm going to go ahead and click on this box. And then I want to select my data. So notice that I am only going to select the numbers. Excel cannot compute letters. It can't compute words. It can only compute numbers. So you only select numbers. I'm going to go ahead and hit OK. Now it starts to give me a graph, and one would think, oh, great. The problem is it's not graphing your Y values yet. So we go back over here to series, and I'm going to add series. So adding my Y values, so adding these in, now gives me my X, Y coordinate. And we never, ever, ever use a bar graph. We always use a scatter plot. So I went up to chart type. I'm going to scroll down to scatter. Now looking at this, I'm missing a couple pieces. So let's go ahead and customize. And let's go to chart and title. So I do want to have a title, which is radius versus time. So that now puts my title at the top. And I'm going to click there again and go to my horizontal axis title. That horizontal axis title is going to be radius. And notice that I'm also going to put in the units. We never just want to write something without a unit. And then let's go ahead to our vertical axis and put in time, which has the units of seconds. So now I'm starting to have a little bit more full graph. So looking at this right off the bat, I might not be able to tell what trend this is. So back up and customize, we're going to go to this series button. And this is where it has a lot of information for us. So we want to go ahead and scroll down to trend line. So we're going to add a trend line in. And right now my trend line is linear. And we're seeing that, ooh, this isn't looking too good for a linear trend. The other button that I can choose is show R squared. So an R squared is pretty much your confidence level that what you're looking at is indeed following that trend line. So right now I only have 82% confidence, so I was only 82% accurate with a linear trend, and that is way, way, way too low. We want bare minimum 95% and above. And that is bare minimum. So clearly this trend is not linear. I can see that by the graph. I can see that by my R squared value. So let's go ahead and change it to exponential. And I see that I have a 95% confidence interval, which is what we want, or polynomial, which is only 93%. So clearly this is going to be an exponential function. But what we would call it, and if I take a look at this chart, it's more so an inverse relationship. That's what we would say. So knowing that this is an inverse relationship, I now know that I have to linearize. So this chart tells me that in order to linearize an inverse relationship, I need to take all of my x values and do 1 divided by x. So down here, I'm going to make a new chart, and I'm going to say this is 1 divided by the radius as my title, because it's no longer just radius, it's 1 divided by the radius. And same thing with my units. It's 1 divided by meters. Then time, I know, isn't going to change at all. And I'm going to go ahead and select my Y values, copy, and bring those right down because I know that nothing's going to change with them. And then at this point, what you can do is you can either do the math in your calculator. I'm just going to show you how to do it in Excel. So I'm going to do equals 1 divided by, and then divided by the cell that I want to work with. So this is A3. So 1 divided by A3, and then hit enter. And then it does the math for me. And now that I've put in that equation, if I go to this square right here and drag it down, it's going to use that same equation for each one of those points. Now, there are way too many decimal places there, so I'm just going to go ahead and shrink those places. What has happened? To 2 decimal places. We always use 2 places. Now, I've linearized my data. I've done what I needed to do, and I'm going to go ahead and regraph to make sure that I've gotten that linear trend. So once again, clicking into a new box, insert, chart. I'm going to just go ahead and pull this down. And then once again, add x-axis. So adding in my new x values. I'm going to hit OK. And then my y's are not there yet, so I can add series. And let's add in my y's. And then we're going to go ahead and hit OK. Now let's go ahead and change that to a scatter plot. And we see when we get that scatter plot, the bar graph wasn't actually showing us what we needed. The scatter plot, though, is now showing us a much more linear trend. It's not perfect because this data collection was definitely far from perfect. It did contain some errors, but it's still now showing me a much more linear trend. So let's go ahead and back up to my customize. I'm going to add in my titles. So this is now 1 divided by the radius versus time. And my x-axis, oh, I'm sorry, that was the vertical. The vertical axis should just be time again. And then my chart title should be 1 divided by the radius versus time. And then my horizontal axis is 1 divided by the radius. So following through with what I've done to linearize. And now going down to series once again. I'm going to go ahead and add my trend line in. In this case, I do want it to be linear, and let's go ahead and show that R squared. I now have a 98% confidence interval, and that's where we want to be. So I can confidently say that my manipulation formed that linear trend. And this is where we start to look at our mathematical models, starting with y is equal to mx plus b. Now, what I would write, y means something in physics. So y means time. So it's time is equal to my slope, and that should be a value. Right now, I don't know it. You should be able to calculate it, but we're going to get to that in a second. And that slope is multiplied by my x. So what does x represent? Well, it represents the radius. And unfortunately, I am running out of time. And it's not just the radius, it's 1 divided by the radius. And we go ahead and add whatever our b value is, so whatever that y-intercept is. So if I go ahead and click back on my graph and I go back into series, I can go ahead and go to label, custom, and I want to use equation. So right now I have my equation. So it should be y is equal to 0.349 multiplied by x plus negative 1.134. Well, this is your mx plus b. So without actually doing the math, I already have what I need. So I have time is equal to my slope, which is that 0.349. And I know that I need to put units in with numbers. So in this case, it's supposed to be the change in y over change in x. So it's seconds divided by 1 over meters, which really, if you do keep change flip, would be seconds times meters. But make sure that you put those units in. And then this whole thing is being multiplied by 1 divided by the radius. And then we go ahead and add in our b value, which was that last number there, which was negative 0.134. And since it is the y-intercept, it has the same units as the y, so it is seconds. And this is what I was ultimately going for, forming this mathematical model. That is always our goal, because now, no matter what numbers you would put in, you would be able to get an answer. So let's say I had given you a problem where the radius was 1 meter. You would be able to plug in 1 meter and tell me how long it would take to conduct that experiment. So that's kind of a quick tutorial on linearization and how to actually graph in Excel. Good luck with your 4 problems that you have to do. Email me with any questions.